do a back projection. So we obtain here B of x and y. And then you have to go from here to here, and this you can do it by a convolution. Actually, it is, but this convolution, it is not very easy to do, because this function, this impulse response function, goes to infinity at 0. However, main operation can be done here in 2D convolution. It would be interesting to, if I want to continue in these equations in this form, I see that it is not very, we have to have much more time to go through these equations and detail all of them and so on. So it may be a little difficult to continue in this way, and this is not the subject that I want to follow. Let's go and discretize this forward problem. Okay? As we did for the convolution, first we explained the things in the analytical form, and then we discretized the things, and we arrived at a linear system. We are going to do the same thing here. Okay? Before going further in this explanation, we are going to discretize this equation. For discretizing this equation, let me go back in this. Actually, numerical computation in computed tomography needs to do discretization. And discretization, what means discretization? Means that take all this area and subdivide it in what we call pixels. Anyway, you cannot show a function on the computer. What you can show is just the pixel values. Okay? So we are going to discretize this space to pixels. This pixel, I am going to write it F1, F2, F3, F4, and so on. F5, F6, etc., up to Fn. And these detector positions also are discretized, in fact. So this expression, I am going to write it Gi. I is the index of the detector, and J, Fj, is the index of the pixels. And so from Gi going to Fj, I can just write that Gi is a sum over J Hij Fj. And is time? No, just I finished this. And so if I note by this length Hij, we can discretize this equation in this form. And again, if you look at this equation, again we can write it in the form of G equal to Hf. And you can see that these two problems, which are absolutely different, when we discretize, we arrive at the same kind of equation. But the structure of this matrix is different, and the conditions and all the difficulties that we could find here in H again exist. But if we can discretize all these inverse problems after discretization, if they are linear, we always arrive at this equation. So in the next session, we are more going to discuss about this equation how to solve, that we proposed a solution before. But we come back again on this discretization a little, and we describe this matrix, and I will show you also that this back projection operator is just transpose of the matrix. So that would be interesting to show it the next time. So we are going to stop here because the time is past. So the next time we come back a little more on this Radon transform, analytical methods, algebraic methods, and then we follow for this next. Okay, thanks. Thank you.